Hello and welcome back to Spring Boot tutorial. In the previous session, we started building a Spring Boot application. Today, we will be writing some test cases for our Spring Boot application. Okay, so just to recap, we started building a product service which had two endpoints, products and products with prod ID. Okay, so testing. Why testing is important? Testing is very critical to give your production ready code with confidence. As team size and as the complexity of the application grows, without automated tests, you can't deliver or refactor your code with confidence, right? So how many types of tests are over there? So there are basically two main categories of tests. One you can call unit test. Unit test means you are testing a very small part of your class or your application, i.e., it could be a method level, right? It can be as granular as method. Okay, and that's why it's called unit. You are testing a very small unit of your program. The second category of testing could be the integration test. Again, there are two parts of integration testing. One is where you are kind of limited or you are inside your application and you just want to test if one class can talk to another class. Okay, say for example our REST controller can talk to DAO. Okay, so this is called internal integration testing. Second category could be the external integration testing, where you want to test your application is able to talk to external systems such as database, okay, or maybe another service, okay, or another messaging channel, right? So the approach which we are going to take over here is going to be test driven development. Exactly. So you heard of this term, but we are going to actually use this particular approach to write our tests. So how does the test driven development works, and how is it really different from calling maybe just writing the unit test? There is no difference, right? However, there is a just mindset difference over here. Let's first try to understand what is test driven development. In the test driven development, you have three basic parts. You have red category, you have green category, and then you have refactoring. What does that actually mean? So red means you start here. You start here at red. Okay, you write a test. Basically, you're thinking about what you want to develop. Okay, then you start writing a test, and then obviously test is going to fail. Then what you want to do is then you want to implement that particular method or functionality which is going to make this test pass. Okay, so green means think about how to make your test pass. Once you've done that, then you can focus on refactoring. Okay, workable code, how to improve it. Because once you have written a code and your test is passing, okay, you have built a confidence that okay, if I do my code refactoring, if I change, I don't know, maybe just variable name or a little bit of logic inside it, as long as your test is passing, you will be confident in your changes. All right, so this is what test driven development. Okay, so you first write a test, make it fail, and then refactor it. Okay, then make it green and then refactor it. What I have seen in my experience is it's not always possible to do 100% TDD. Reason being, sometimes you need a basic implementation, and then you can write the test, and later on maybe in future you can start writing test cases, and then you can follow this approach. So I try to follow some sort of hybrid approach, and that's exactly what I'm going to do over here. So let's jump back to our code. So what we built in previous session, we built this REST endpoint. Okay, as far as Spring is concerned, there are basically three type of test. One is called SpringBoot test. What it does, it launches internal server, okay, and it's gonna give you all the environment you need to run a web-based application such as this product controller, and then you'll be able to call these endpoints and verify, okay, if I call get products, for example, am I getting the right data? If you call add products, are you able to create new data or not? Are you getting the right responses or not? Okay, so that's what we're going to do. Another type is called web MVC test. What it does, it kind of bypasses that server startup, but then you have to give a lot of mock implementation or stub implementation. We're going to try that as well. Third would be the normal unit testing, where you are taking a class okay, and then you're testing a public method over there. So I am going to start with testing our REST controller, okay, and for that I'm going to use Spring Boot test. Even before that, what we like to do is we like to write a very simple vanilla test. What it's simply going to do when your application, when you're building your code and when you're testing it, it's simply gonna check all the dependencies are over there. Like, okay, are you able to build Spring context? Yes or no? So that kind of gives you the confidence that, okay, all the things are working fine. After that, you can start adding more tests. So without further ado, let's just create a very first test for our Spring application itself. Okay, so the shortcut in IntelliJ is if you press Command Shift T, okay, over here somewhere, yeah, it's saying create new test. So just click on that. I'm going to use JUnit 5 to test my Spring Boot application. Okay, you don't need anything, you simply say okay. Yes, let's add to our unit. So the first thing you want to do is you want to decorate it with Spring Boot test. Very simple. Okay, what is Spring Boot test? Let's just go to the documentation. It's saying annotation that can be specified on a test class that runs Spring Boot based tests. Okay, provides the following features over and above the regular Spring test context framework. These various things, you can read the documentation, right? So as I said, what we simply want to do is we don't want to test any business logic over here. We just want to check whether or not I am able to start my Spring Boot application. So what you can simply do is you can just say public void load context. Just create a empty method and you have to decorate it with annotation called test. Okay, so this is a JUnit 5 annotation which gonna start your application. You can leave a little comment over here, no impl needed, as we are simply loading the context. Okay, it's probably a good practice. It's not a bad idea to having this method, just leaving like that. So it's just simply gonna run and it's gonna make sure your application is loading. And I'll show you what it means by when we have some issues. So we have written our very first it's kind of integration test, you can call it, right? It's an application level integration test. So let's just run it very simply. Run product application test, and you will notice it's actually launching Spring. Okay, that's what you typically see when you start Spring Boot application, right? So as you can see, it's where is gone. Yeah, it's basically starting a Spring Boot application. It's saying this is the version 2.53, okay, and blah blah blah. All these active profiles are running. Okay, it's saying all good. Now what I can do is, how do I make sure this thing is always running, it's not just giving me any dumb answer, right? So what you can do is go back to your product controller. If you remember the dependency injection which I was talking about last week, okay, or in the previous session. So let's say I try to put something over here. Let's pick up something called whatever came in my mind. Let's say what we can do is I just want to put something like database driver, okay, and I'm just going to call it foo. What it simply means is we are expecting Spring to find a bean called foo of type database driver. Over here, this is not a compile time issue, by the way. Okay, as you can see, so IntelliJ might be showing you that this is a compile issue. It's not. Okay, however, this is a runtime problem. So if you had your test written, at least this test written, if you try to run it, you will see a problem. It will say I can't find this particular bean. Can you see the load context failed? Even though we don't have any business logic inside my load context, but still it's telling us that, you know what, the thing you specified over here, I have no idea what you're talking about. I could not find the implementation for this database driver class. Correct? Okay, so that's what the problem is if you scroll down, if I go to the load context, over here it's saying fail to load blah blah blah. It's saying set up request context if necessary. Yeah, see over here, it's saying error creating bean with name product controller. Okay, of course this is our bean, and somewhere over here it should say no qualifying bean of type database driver with the name I have given. It is expecting. So this is how you build your confidence. Okay, now if you're just wondering, is it not a compile time issue, I can simply say maven clean and I can say skip test. Yeah, if I say skip test, you will notice our code will compile successfully. Build is success. So these type of things you can catch early in the stage, right, where your code is compiled and you're kind of trying to give it to your customer, and when they try to run it, boom, it failed. But if you had this test, you would not be able to build your code. If I try to do now, maven clean test install, or even without install, test is always going to run. If you try to do that, the build will fail. So let's say if you have a pipeline will complain saying, look, I can't find it. So catching errors earlier is very, very critical. I hope you got the idea. Okay, and you can see the benefit of having a just plain empty implementation because you are loading the context. Okay, let's just come back to our product controller. So how do we test our product controller? Let's clean this class. Let's write a test, because we don't have a unit test. So TDD is not started just yet, but let's say we are starting fresh. So first thing what we can do is, now we are testing our product controller test using again SpringBoot test. Okay, so as soon as I define SpringBoot test, when I start my application, it will launch product controller in internal server. What Spring has done, they are very clever basically. So because if I try to start my application, obviously it needs to launch internal server. Sometimes you can have a port clashes. Let's say like it's internally using 8080. There is always a possibility like there might be some sort of port clash. So what you can do is, on the SpringBoot test, you can define that my web environment is going to be random port. Okay, you say web environment equal to random port. Let's just do a static import on that, so we have a just nice and clean line over here. So what you need to define is, you say this is a SpringBoot test, but when you start this application Spring, please give me the random port. So question is, I have given a random port over here, but how do I consume inside? Another nice way of doing it is, you can simply say at local server port private integer port. So Spring automatically is going to inject or provide the value of the port where it's starting the application on this particular variable. Now we are good to start our application or test development. Okay, let's write very first test called public. Just don't forget to decorate it with test. Okay, and it doesn't have to be public. You can simply say void. The approach typically I like to take is like, I like to give my method names really descriptive. So I can say given products, okay, get products endpoint should return products list. Clear enough? We don't need to do any documentation. So if anybody is reading it tomorrow, they know exactly what we are talking about. So we're saying given products list, okay, given products data, get products endpoint should return products list. Perfect. Okay, let's just build a base URL over here, so we kind of reuse it maybe if needed later on. So what we want to do is, we are saying my application server is running on localhost, but I don't know about the port. So this is where the port is going to be handy. So let's say plus port, and what is our endpoint? We have something called products. Okay, let's just have a quick peek over here. So we are saying this is what we are trying to invoke, /products. Say /products over here. Perfect. Now how do I now talk to my server? Okay, you need some sort of like API which can talk to this base URL, correct? So what Spring has done, they have given another very nice utility called test rest template. It knows exactly how to talk to your server. It knows like how to make a request, get the response, serialize, deserialize, all that type of good stuff. So you simply call it rest template, okay, and we need to auto wire it. We done the auto wiring over here. Now we are simply going to say rest template get for entity. There are several methods inside this utility. The one I'm going to use it is called get for entity. Why I need to do that? Because then I'll be able to specify my DTO where I want it to deserialize the data for me. So I'm saying please go and talk to this base URL, and the data which I'm expecting from this controller is, it's called product DTO. Okay. Interesting thing is like even though we are returning list, but JSON would basically kind of treats it as array. So we have to simply say array. Okay, this is a nice and clean way. If you wanted to still kind of put it into list, etc., there are some complicated ways. You can search on Google. There is a thing called arguments or something. Okay, but I think this is just good enough for us. So what you can do over here is you can simply say response entity. It returns a response entity and it's gonna be type product DTO. Okay, it's gonna be because that's what we are asking our REST template to return it. Oops. So we are expecting a product DTO array to be returned, and let's call it response. Okay, so we got our response back over here. Now let's start verifying our response. So how do you do that? There are some assertion methods, okay, inside JUnit 5. We are going to use that to verify our response. So we can use something called assert that response. Okay, and it's asking where do you want to import. I'm going to say import from org assertj.core API dot is equals. So let's just check the response get status code, because HTTP is going to return a status code. So we are saying give me HTTP status okay. Okay, you can write 200, which is fine, but I'm gonna use like everything given by various utilities or constant classes. Okay, perfect. So what we have done over here is we made a request to this URL. Now we are just verifying that my server is able to return 200 okay when I make the call. Perfect. Let's just run our test. Just in case if you are wondering like where this Spring Boot test and all these things came, just remember when we created our project on Spring Initializer, it already had a dependency called Spring Boot Starter Test. It has JUnit 5. Okay, it has all the assertion libraries. All the dependencies are already part of your project. So the only thing hopefully you have used start.spring.io. If not, this is the dependency you need in your project. All right. So we have now written our very first test over here. This is like a internal integration test. Let's just run it. Product controller test. If everything good, we should be having a green test over here. Beautiful. Okay, so we got our test completed. It got whatever we asked it to. Let's just enhance our test a little bit. What we want to do is, as a next step, I am saying let's just check the length of the message, right? So let's just say get body. So this class called response entity has something called get body, and you can say dot length is equal to we can basically say is equal or greater, is greater than or equal to 2. Why I have that? Just in case, like, if we add new products. So right now we have just added 2 products in our DTO. When we start application, by default it has 2 products, right? You remember that we added 2 products, Sony 65 and Sony TV 55, and that's what is going to be returned over here. So I'm simply saying check the body size, it has 2 products. Okay, if you rerun your test, it should run real quick. Okay, and it's gonna verify that yes, you have 2 products. Now let's say everything is good. Tomorrow one of your team members decided to add a new product over here. What will be the side effect of it? Let's just verify it. So if I take this is one product, this is second product. Let's say somebody comes tomorrow, they decided to add another TV over here called Sony TV 75. Price is maybe 3,000 or something. Okay, and if you try to run your test, do you think it's still gonna work? It's still gonna work. Reason being, because we have asked for equal or 2, greater than or equal to 2. If we had used another method called just equal to, it would have failed. So there are ways, like, if you really wanted to be strict like that, or you are flexible, because these type of things can be added as long as it's not changing the functionality, right? Cool. So if I run the test now, it's still gonna work. That was the reason I used this method called is greater than or equal to. This is just a guide, like, okay, perfect. Now let's just try to do proper what you call test driven development. Okay, how do we do that? So what we have in our post method, let's quickly copy and paste this thing, and now let's start testing the other endpoint, which is basically test, and let's call it given a new product. Okay, post products endpoint should add a new product, Good. Okay, so let's just write a very simple test first. So we have localhost products, that's good. You can define as a constant, but let's just keep it simple for now. So what we want to do over here is we want to now use another method called post for entity. Okay, so what we want to do is we are saying instead of get, use post for entity. Base URL is fine, and over here what you need to pass, you need to pass a product DTO.class. Also you need to give, let's say, product Samsung. So this method called post for entities takes 3 parameters. Okay, the base URL, your payload, you can pass a class and it's automatically going to serialize into JSON, and as long as you can tell what is the type of the data you are passing. So what we need to do is we need to create this local class called product Samsung. What I'm going to do is I'm going to do a little bit of cheating over here. I'm going to go back to product DTO, and as you can see, we already have this bean over here. Let's just quickly copy paste, okay, and refactor as per our need. So I'm going to simply copy paste this thing over here. Okay, and let's say, please give me a local variable, and let's call that local variable product Samsung. Okay, because that's what we need to pass over here, as you can see. Now obviously because we are creating a product, if you remember from the previous video, our product ID is generated at server. When you make a request, that's the only thing you need to do. Okay, good stuff over here. So obviously it's not happy because we are not returning the array over here. Okay, remember, whatever you pass over here will come as part of your response entity. So that error is gone. We can get rid of this for now. Okay, when you make this call, let's try to run this method. Okay, and then we'll start doing the proper TDD. Okay, at this point, I know we are already 15 minutes into the call. We haven't actually started doing the TDD, but this is the point we will start doing the actual TDD. Okay, good stuff. So our product was added into the store, and then this method is happy. Now let's say business says, okay, you know what, I don't want HTTP status okay, instead I want HTTP status called created. Remember 201. This is typically a server returns successful, right, saying yes, some sort of data has been created. If you were just posting something but you're not expecting something, you can return 202. But because we are creating a new resource on the server, instead of 200, which is just okay, I like to return 201. Now if I run this test, what's going to happen? It's going to fail. Why is it going to fail? Because server is still returning 200. So this is the proper TDD. You define your behavior, you make the changes, okay, make the test pass, and then start refactoring. So first thing we want to do is we're going to come back to our method over here, and first thing we will say, you know what, whenever a product is added, let's store into a local variable, introduce local variable. Let's call it created DTO. Okay, doesn't matter what it is, but yeah, reason why I have created DTO, because what I'm going to do is in my add product, okay, I'm already returning the updated or new DTO, so we can now notify our clients. Over here I'm saying return response entity, okay, response entity, and in the response entity, what I like to return, I would be saying give me a data response entity dot status of what we want, created. We want status created, as well as we like to send this data to our body. Okay, created DTO. Obviously it's not happy because it's saying your return type is not matching, so we're just gonna stick our response type over here. There we are. So we, following the TDD approach, we had a failing test. Now we made the changes. Okay, forget about the refactoring for now, but at least now we have write the code to make test pass. Okay, let's run our test case. Hopefully it's gonna work. Perfect. This is proper TDD. You define the behavior, then you write the test cases. Cool. Perfect. Okay, so one more thing we can do is, let's say, just reverting back, if I did not have this body, okay, dot created dot build, I could have simply said build. Now let's say I forgot to basically write the response. Okay, so at this point my test still should be working. Yeah, perfect. Now let's say I said response dot get body, and let's store the body to local variable called new DTO. Okay, if I start inspecting that, and if I said assert that new DTO dot new DTO is not null, okay, let's say our business requirement came and said, like, when I create a new resource, I would like to return it immediately as well. Okay, so if I do that now, we are making a test failure first. It should fail. It's failing. Reason why it's failing? Because I'm not returning anything. Okay, which means time to implement new behavior, like that. If I run the test, because I have started returning the data now, this test should pass. Perfect. One more thing we can do is we can now start adding more and more behavior. I can start saying assert equals Okay, there is another API. Assert equals the product Samsung DTO which I gave you earlier, get the name of it. Okay, just make sure the new TTO which is getting has the same product ID. Okay, assert equals that. Okay, and second thing you can say product names should be same. So this message will be written when products are not same. Okay, so let's say I write that. Okay, this gives me the confidence. Now tomorrow if somebody decided, if I come over here, let's say, like, no, just to tell you how things can go bad, let's say somebody tomorrow decide to say, whenever you have a name, what you like to do is maybe take the original name which was there, product dot get name, you suffix with something saying I don't know, my shop. I'm just making up a story. I couldn't think of a better way. So let's say somebody, some developer came and start messing up with names. If I had my test cases and if I try to build my application, it would fail. Why would it fail? Because I have this safeguard over here, and my IntelliJ is saying this method failed. If I go to my test, I should have a proper saying I expected. It's saying product name should be same. Okay, this is the message. It's saying expected this, but actually server is returning me this. So there is something has to be fixed. Somewhere something has to be fixed, which means either I should be fixing my test or I should be reverting back my unnecessary change. So this is how you safeguard yourself against the unexpected errors, by having proper test cases. Hope it makes sense. All right, that's beautiful stuff. Okay, going back to our TDD slide, you must be wondering what is refactoring here doing. You can actually go over here and you can improve your code. How can I improve code? Currently I'm kind of defining into a local variable, but then suddenly I decided, hang on, I don't even have a need for local variable. What you can simply do is you can just put it over here. It's refactoring one way or another. It is a refactoring. Okay, if I run my unit test now, or my local integration test, I can refactor my code with the confidence that it's not going to break. Make sense? Perfect. Okay, so I think we have now covered how to write integration tests using Spring Boot. Okay, by using a thing called Spring Boot test, and this thing is annotation. Okay, the second thing which I said earlier was, like, how can I write unit tests? So this is integration test, this is good, but how can I test just these two utilities? So let's just write very simple unit tests, very simple unit tests, covering, again, Command Shift T is your best friend. Okay, so let's just write test. We don't have to decorate, I hope, with anything, as long as you simply say test void given pre-populated data. Okay, what method we want to test? Let's close this class. We don't need this. This was all good. Get products. This is the method we are testing, by the way, right? So we are saying get products should return a product list. We are not using any Spring dependency, etc. We are just doing a pure unit test over here. Okay, how do you do pure unit test? You simply say, okay, look, I am going to manage the life cycle of this class. So you say product DAO equal to new product DAO. If it was done by Spring would have done all these things for us, but we don't care. Now we are simply saying assert that, okay, DAO dot get products dot size. Okay, let's just import this class from import static, yes, from our core dot. Let's see what methods we have. So what we can test is we can actually put something called is equal to 2. Okay, let's be very strict, saying okay, just check whenever this class gets initialized for the first time, the size is 2. Okay, I'll tell you why I'm doing that. So let's run this method. Hopefully it will work. It did not. It's saying expected 2 but was 3. Sorry, it should be 3 because the size of this product list is 3. Okay, so let's just say size 3. Okay, this method is done. Perfect. So we managed to test that whenever I call this method called products, it's going to return a product list. Okay, and then it has a size of 3. This is good. Now let's write the second test for add product. Okay, how we can do that? Just copy paste. Okay, and then say given a new product DTO, add product should add and return DTO with prod ID. Okay, so let's start with this very simple thing. Again, you define DAO. You can actually start with saying assert 3. That's good. Now let's just, what we can do is we can again do a little cheating over here. We can go back to, oh, not this one. Where is our controller test? Yeah, over here. Remember we defined this, where is, yeah, this one. Let's just copy this thing, paste over here. Let's say I'd like to add product Samsung to my API. So say DAO dot add product for me, please, product Samsung. Okay, now it has added. Let's just, because it's returning a new DTO as well, let's just call it created DTO. So what I can check over here is I can check for a few things. I can check, first of all, created DTO is not null. Also, created DTO has ID. Okay, another thing I can check is I can check when I call the get products again, the size is not equal to 3. It's basically has incremented to 4. So let's do this thing first. As soon as you have added a product, if I call this method with 3, it's gonna fail. Instead, I'm going to say it should be 4. The size of the list must be increased. So let's just run this test. Good. Okay, as you can see, earlier it was 3. As soon as we added a product, the size has become 4. Perfect. Now let's start testing our created DTO. So if I say assert that DAO dot get, just do one thing. Let's just hide this thing so we can do a proper a test driven development. Let's say this thing was not here, and if I put a logic saying get assert that DAO, sorry, not DAO, assert that created DTO get product ID is not null. All right, so if I do that, this test is going to fail, because when we sent product Samsung, we did not have ID. We are expecting server to create that for me. So now this test will fail. So what we can do now is it's saying, oh, expecting actual not to be null. Okay, so this line failed. Come back, and now remove that, and when we get the response back from server, see, our test is passing now. So this is how you do test driven development. you make it fail, then you improve it, okay, you make it pass, and then later on you can do refactoring. What refactoring can we do over here? Okay, we want to get rid of this thing as well. Okay, so this is a kind of refactoring, isn't it? Also, we can say, let's define this into a constant. Okay, actually let's first make sure our test is still passing. Yeah, let's say I want to do a refactoring that, you know, as far as product ID is concerned, I'm kind of hard coding things, P plus ID. Okay, this is quite cumbersome, right? Tomorrow if I have to change the logic, I have to, you know, make so many changes. Instead, what I can do is I can extract this thing into a method. I can say create ID, create and get ID. Let's write this method called create ID. Okay, what this method is very simply going to do is it's going to say P plus ID. Now we can very safely replace this thing. Okay, everywhere we kind of had hard coded our logic, even over here. See, this is a kind of business logic, right? Where we are creating now we are relying on this method called create and get ID. Doesn't matter what business logic is inside, at least we managed to do a lot of refactoring over here. If I run my test, it should be passing. See, with confidence, I can now make the changes. All right, I think we can finish this session over here. One thing we can do is, you don't have to run these tests individually. Okay, you can right click over here and you can say run everything. Second thing you can do is, which is basically, let's say you have some sort of Jenkins pipeline. Okay, this is the command your pipeline will be running, right? Install, and automatically it's going to build your code, run all the unit test cases. As you can see, okay, the unit test case is running. Perfect, build success. Yeah, just to show you, it ran all these tests. Okay, it ran 0 failures. Okay, yeah. Okay, I hope you enjoyed this session. In today's session we learned how to write Spring Boot tests. Okay, how we can test REST endpoints. We also learned test driven development. Thanks for your time.